Hi guys, Mr. Wilson here, and this is the final video for day one, and it's all about surds. So, to start off with, we're going to look at adding and subtracting surds. These are really simple if you treat it like algebra. If you treat this as like, well, this is one thing, so let's call it A. This is exactly the same thing. The mathematics behind both of these questions is the same. So everyone knows this is 2A, but for some reason now get confused. So it's 1 root 2 plus another root 2, well that's 2 root 2's. So here we have the same like surd, so 5 of them plus 2 of them, so 5 root 3's plus 2 root 3's is 5 root 3's. So 5 root 7's take away a single root 7, if you like you can put a 1 there, well, that's 4 root 7's. So that's pretty simple, but a lot of people make a mistake on it. Now multiplying surds, this one is, I don't expect you to remember anything, I always expect you to be able to work it out. So what I do when I get a question like this, if I'm ever stuck, I reinvent it using questions that I can easily square root. So that we know is 2, and that we know is 3, and therefore 2 times 3 is 6. So what would be under my root value to make that 6? Well, 6 squared is 36. Now if you look at this question, you can see, what do you do with these numbers here to get 36? Well, you times them, which means I can now work this one out. If I just times them, so 5 times 3 is 15, and there I have it. So if you get a question like this, for example, well, root 3 times root 3 is root 9, or simply just 3. Now it can get a little bit trickier, so if you've got 4 root 2's times 3 root, say, 5's, well, again, if it was 4a times 3b, I'll just write that down, you would deal with this bit first, so let's do that, and that'd be 12. And here you would just do ab, so we're going to do something really similar, so it's just like this top one here, root 5 times root 3, we just times them, so root 2 times root 5 is root 10. And there you have it, that's the answer. Now, using those two skills, we now ask you to simplify, and if I'm honest, you're most likely to get asked something in the next video. The first two previous bits are the basics. So to simplify surds, what we're saying is this isn't a surd because it's not in its lowest form, it still has what we call square factors. Now to do this, you need to think of your factors and a 45. So if I do this one, 1 times 45, we've got 9 times 5 is 45. And you should be able to see that from this one, I can write it as 3 root 5's, because the square root of 9 is 3. So what we say, this is fully simplified. Now, I could also write that as 1 root 45, but that is the question. So what we're looking for is square numbers and the highest possible square number, or square factors, I should say. So I'll take this one a bit slower as well. So we've got 2 and 6, we've got 4 and 3, and obviously we've got 12 and 1, but I'm not going to include that one. So from here, none of these numbers have a square root, so that's useless. But this one is 2. So that's 2 root 3's. And if you notice, I've always written my square numbers first. That generally helps you reach the next level. Now, sometimes it's a bit trickier. Take this one, for example. I can tell you that that is 9 times 8 is 72, and 9 is a square number. So my thought process to get that was, what are the factors of 72, one of them being a square number? And that is 3 root 8. If I wrote that, I'd be wrong, because I can also say root 8 is 4 times 2, and that there, root 4, is 2. So I've actually got 3 lots of 2 root 2's, which I just told you was 6 root 2's. Now, that's a lot more working, and the reason there's more working is because how I started is not the highest square factor, but it doesn't matter as long as you keep going, as long as you keep saying to yourself, is there any square factors? And if there are, you keep going. But you'll see, if I wrote it like this, 36 times 2, I can go straight to my answer. So it's always in your main interest to get the highest square factor possible, But if for some reason you can't see it, you just keep going until you're finished. That's a nice way of checking that 6 squared is 36. So you can go back the other way. Now, one of the main skills is what we call rationalizing the denominator, with a surd being an irrational number because it goes on forever and ever. So what we've got to try and do is take the denominator and make it a whole number. Now, if we look back here, I showed you that when we multiplied surds together, which were the same, so root 3 times root 3 is root 9, or just 3. So we actually got rid of the surd and made it a rational number. So let's go back to this one. I've therefore got to times this by root 3. So I'm always timesing by the surd. Now if I do this, I'm going to change the whole fraction, and I don't want to do that. I want to make it not have a surd on the bottom. So I have to do the same to top and bottom, leaving me with 5 root 3's, root 3 times root 3, which is root 9, or simply just 3. Now, they might ask you to go a bit further sometimes. Let's say, for example, that was, well, for argument's sake, let me just change that to a 6. And therefore, that would be a 6. And you should be able to see, well, if I've got 6 root 3's and I'm dividing it by 3, I'm finding a third of them. And 3 is a factor of 6. So this is the same. So they might ask you to look out for numbers that will simplify here. So similar process, I need to rationalize this, so I need to times this by root 2, and therefore times the top by root 2. Now this is a bit more trickier because you've got 2 terms you need to multiply by another term. So we normally do that using brackets. Root 2 times root 2 is root 4, or just 2. So I'm going to multiply the term outside by everything inside. So root 2 times root 3, well, that's root 6, plus root 2, all over 2. Neither of these have square factors, so that is my completed answer. Now, it still gets harder, so I'm going to have to show you a couple more things. Just bear with me while I fold this paper over. So, expanding surds is one of our favourite things to ask you. So, depending on how you expand quadratics, I would get you to do that. But the fact that you're trying to learn surds, it means you're an A or A star student, so you should be quite fluent. So, 3 times 4 is 12. If you have no idea what I'm doing, then you must watch a video on expanding quadratics. So 3 lots of minus 3 root 5s, well that's minus 9 root 5s. Remember, if that was an A, 3 lots of 3A would be 9A. So same maths. So positive times a positive, so I know it's a positive number. 4, if that was an A, it would be 4A's, so it's 4 root 5s. And here we have 3 root 5s times a root 5, so it's 3 lots of root 5 times root 5, which is root 25, which of course is 5. So let me tidy this up a little bit. So we've got 12. If we're starting on negative 9 root 5s and we're adding 4 root 5s, well, we're going to end up on that. Please, again, if that was minus 9a plus 4a, you wouldn't hesitate to write minus 5a. So just think about it. And this is 5, and there's 3 lots of 5, so that's 15. So we can tidy these two up a bit more. 12 take away 15 is minus 3. So here is our answer for that one. Now, this one's a really special one. I'll just do it a little bit quicker. So that's root 16, or just 4, minus 3 root 4s. I shouldn't have chose this number because that's obviously 2, but just bear with me for a second. And that's plus 3 root 4s. And that's minus 9. And you should be able to see that those two will cancel each other out. So we've got 4, take away 9, which is minus 5. I've completely removed the surd and therefore rationalized it. So sometimes, if they're really mean to you, they would give you a question like this, asking you to rationalize the denominator. So what I just showed you is to remove the surd, you actually have to times it by pretty much the same thing. It's very similar to the difference between two squares, but the signs change. So what I've actually got to do is times it by root 5 minus 1. Exactly the same, but swap the signs over. So I'm ending up with this. Now you might want to do this separately somewhere else, but I'm going to do it very fluently now, so please try and follow. So that'd be root 15. So I've got minus root 3. So the second term multiplied by the first term, that's minus 2 root 5s. And the last terms multiplied together, it would be a positive 2. Root 5 times root 5 is root 25, or just 5. Minus 1 root 5 plus root 5. Well, I'm not going to write anything down because they cancel each other out, and that would be minus 1. So this top bit I can't actually do anything with because I have no like surds and this hasn't got any square factors. So sometimes it is as ugly as this one, but sometimes it actually cancels down a bit further. If there was another root 3, for example, I could collect them, or another root 5, but there isn't. And that's 5 take away 1, which is 4. So if you're on an A star, you should be trying to follow that. If you're not, then I wouldn't bother. But that is the hardest surd question they could probably ask.